Okay, so today I have to start with cohesion compound. Okay, cohesion chemistry. Okay, so already always I say that is cohesion compound or cohesion chemistry is very much important in point of views inorganic chemistry, not only in CSI net but also for PGT chemistry, but also for BSc MSc, but also for WB set, all types of slate exam and set exam, and also for obviously for bark exam, so many exam, that is gate exam, because this is a foundation, this is a base of inorganic chemistry. If you never know about cohesion chemistry, then organometallic, you never understand inorganic chemistry uh, with a much broader area. Okay, because these all are basically foundation, these are the base of inorganic chemistry. As for example, in organic chemistry you have to know first GOC, general organic chemistry, like as for example the basic fundamental thing, that is hybridization concept, that is catenation property, that is electronegativity, that is inductive effect, resonance mesomeric effect, hyperconjugative effect, aromaticity, anti-aromaticity, annihilation effect, homolog activity, electrophilic substitution, the reaction mechanism. So all are the basically basic part of organic chemistry. If you never know this, you never attend the higher organic chemistry. Okay, if you never know the reaction mechanism, you have much more problem to understand the pericyclic reaction. Okay, if you never know the homolytic fission, there must be so many problem when you read photochemistry. Okay, so that's why organic chemistry is based upon general organic chemistry. Okay, based upon general organic chemistry, and inorganic chemistry based on cohesion chemistry. Cohesion chemistry is the most important chapter of inorganic chemistry. Okay, क्लियर। ओके, आपका जो इनऑर्गेनिक केमिस्ट्री होता है उसका सबसे इम्पॉर्टेंट चैप्टर होता है कोएशन केमिस्ट्री। और याद रखना, जब आप सी एस आई नेट एग्ज़ाम दोगे तो वहाँ पर सबसे ज़्यादा क्वेश्चन, सबसे ज़्यादा वेटेज क्वेश्चन होगा फ्रॉम कोएशन केमिस्ट्री। ओके, सो आपको ये मिस नहीं करना है। इनऑर्गेनिक केमिस्ट्री में कोएशन केमिस्ट्री, ऑर्गेनोमेटालिक, बायोऑर्गेनिक और ऑब्वियसली मॉस पावर, ईपीआर, ईएसआर, स्पेक्ट्रा, एंड लास्ट वन ए ब्लॉक नहीं छोड़कर मत जाना। क्योंकि आप फिजिकल जितना भी करो, प्रैक्टिस करते रहो करते रहो करते रहो, अगर वहाँ पर न्यूमेरिकल टाइप क्वेश्चन आ जाएगा और वहाँ पर कोई भी आपका मिस्टेक हो सकता है, कोई भी कैलकुलेशन में प्रॉब्लम हो सकता है, कैलकुलेशन में मिस्टेक हो सकता है, यूनिट कन्वर्शन में मिस्टेक हो सकता है, और फार्मूला याद नहीं आया ऐसा भी हो सकता है। तो इसलिए फिजिकल केमिस्ट्री कभी कभी क्या होता है, लोगों को डुबा देते हैं। ठीक है, इसका मतलब ये नहीं है फिजिकल केमिस्ट्री छोड़कर जाना, दैट इज़ नॉट दैट। बट इन फिजिकल केमिस्ट्री में आपको बहुत सारा प्रॉब्लम फेस करना पड़ता है। और ऑर्गेनिक केमिस्ट्री क्या होता है, आपको लगेगा ऑर्गेनिक केमिस्ट्री इज़ वेरी मच ईजी टू अटेंड। okay, but they always remember there must be always for each and every reaction mechanism have some exceptional criteria, and from CSR net there must mostly the exceptional reaction mechanism that should become. Okay, so that's why there may be you think about that is this option will be right, but actually that is not so. Okay, so that's why the most of the people, I said that you have to prepare well in organic chemistry and physical chemistry, but never skip inorganic chemistry. Okay, so, and obviously you have to prepare about cohesion chemistry. This is very important. And from my experience, I always have a weakness on our cohesion chemistry, so I prepare myself on cohesion chemistry, and now I am so much strong about this chapter. Okay, so that's why you have to make yourself strong on this chapter. Okay, like me. Okay, so now I have to start from beginning. Okay, and the speed will be so much during this question chemistry classes, because CSR net exam that should be coming so much uh, nearer. So that's why we have to take the all the classes with faster, even faster speed. Okay, so now we have to start with cohesion chemistry. There the initial concept is there must be metal bind with ligand. Okay, and then there must be complex compound that should be produced. आपका जो मेटल होगा वो लिगेंड के साथ बाइंड होगा, मतलब क्या होगा, जुड़ेगा, उसके बाद क्या होगा, कॉम्प्लेक्स कंपाउंड प्रोड्यूस होगा. ओके, अब आपका क्वेश्चन आएगा मेटल क्या है और लिगेंड क्या है और कॉम्प्लेक्स कंपाउंड या फिर कोएशन कंपाउंड वो क्या है, राइट. व्हाट इज मेटल, व्हाट इज लिगेंड एंड व्हाट इज कोएशन कंपाउंड. नाउ the question is genuine, obviously. So metal is nothing but that is a electron deficient, first one, that should be mostly cationic or neutral, and that bind with the electron rich species. Okay, these are called as metal. Okay, and ligand, they may have lone pair or may have negative charge. Okay, that means they are electron rich species, and that's why they always try to be donate their electrons to the metal. Okay, and by this donation and acceptance of electron, they make an interaction, they make a bonding, and this bonding is somehow coded bonding. Why? Ligand donate its lone pair donates its lone pair to the metal, and so the bond that should be coded bond. Okay, you know, in covalent bond there should be a mutual sharing of electron should be there. जब भी आपका कोवैलेंट बॉन्ड होता है वहाँ पर क्या होता है, इलेक्ट्रॉन का म्यूचुअल शेयरिंग होता है, दोनों एक एक करके इलेक्ट्रॉन देगा, उसके बाद एक बॉन्ड फॉर्मेशन होगा, राइट. आयनिक बॉन्डिंग में क्या होता है, एक कैटन एक एनायन खुद के साथ क्या होता है, इंटरेक्शन करता है, इंटरेक्शन करके वो बॉन्डिंग करता है, वहाँ पर कोई भी शेयरिंग का बात नहीं होता है. इन आयनिक बॉन्डिंग देयर शुड बी नो शेयरिंग, देयर मस्ट एक्चुअली द इंटरेक्शन, strong interaction, strong electrostatic interaction between cation and anion. That's why ionic bonding can be there. Okay, and covalent bonding there should be mutual electron sharing. That means each and every two elements give their respective one electron each, and this each electron make a one single bond. Okay, but coded bond is somehow defined. There should be one electron donor, other should be electron acceptor, and electron donor donates its lone pair or negative charge to the acceptor, and that's why their arrow that should be signify coded bond. That means arrow, this arrow towards the metal, that means this ligand donates its lone pair to the metal. That's why this arrow signify that. ओके आपका जब भी एरो देखोगे, अगर लिगेंड टू मेटल ऐसे एरो देखोगे, मतलब क्या होता है, उसका जो लोन पेयर होगा ना वो मेटल को डोनेट करेगा, इसको हम बोलते हैं कोडेड बॉन्ड. ओके, और कॉम्प्लेक्स कंपाउंड में कोई भी कोवैलेंट, कोई भी आयनिक बॉन्डिंग या फिर वैन डर वाल्स फोर्स ऑफ अट्रैक्शन या फिर हाइड्रोजन बॉन्डिंग ऐसा नहीं होता है, वहाँ पर कोडेड बॉन्ड होता है. हाँ, हो सकता है कभी कभी आपका जैसे निकल DMG कॉम्प्लेक्स, देयर शुड बी इन वन part OH is there, in other part O minus is there, there must be hydrogen bonding is there, but this is not a fundamental part of cohesion compound. cohesion compound जो होता है वहाँ पर कोवेलेंट बॉन्ड होता है, और कोहेशन कंपाउंड होने के बाद वहाँ पर कोई भी और बॉन्डिंग हो सकता है, ठीक है, पर कोहेशन जो कंपाउंड होता है वहाँ पर कोडेड बॉन्ड ही होगा. ठीक है, क्लियर. ओके, नेक्स्ट. सो देयर मस्ट बी इलेक्ट्रॉन डोनर and electron acceptor. Two type of species is there, and obviously this electron donor are called as ligand, electron acceptor are called as metal. Okay, electron acceptor is called as metal, and that should be signified as Ml6 to the power n plus minus. Now the question is, L means ligand, M means metal, and you see there must be 6 ligand is there. 1, 2, 3, 4, 5, 6. In picture there must be 6 ligand is there. So here also 6 is there. Okay, 6 means number of ligand that should be attached with the metal. That means coordination number. That means coordination number. आपका कितना सारा ligand मेटल के साथ जुड़ा हुआ है, वो नंबर को हम क्या बोलते हैं? कोऑर्डिनेशन नंबर बोलते हैं. ओके. Now to the power n plus minus. N plus minus means what? That is the charge of metal. आपका चार्ज ऑफ मेटल भी नहीं है. मेटल के साथ लिगन के मेटल के साथ लिगन का जो इंटरेक्शन हुआ उसके बाद मेटल का जो चार्ज होगा, होल कोरिलेशन कंपाउंड का जो चार्ज होगा उसको हम बोलते हैं n प्लस माइनस. अगर आप सोचो एज फॉर एग्जाम्पल, जैसे कोबाल्ट NH3 Cl3, इसका चार्ज क्या होता है? 0 होता है. इसका चार्ज 0 होता है. इसका मतलब एक कोबाल्ट का चार्ज 0 नहीं है. कोबाल्ट का चार्ज +3 है. ठीक है. कैसे काउंट करते हैं? देखो, कोबाल्ट का सोचो X है, NH3 का 0 होता है, Cl का -3 होता है. 3Cl दैट मीन्स -3. ऊपर में क्या होगा? 0 होगा. देखो X का +3 आएगा. मतलब यहाँ पर जो होगा वो होल कोएशन जो कंपाउंड हुआ उसके रेस्पेक्ट में मेटल का कितना चार्ज है. ठीक है. और एक्चुअल जो चार्ज होगा वो आपका ऐसे इस मेथड से आप बाहर कर सकते हो. ठीक है. तो इन कोरिलेशन पेयर इफ एनी anion is present, so on that case anion reduce the charge of metal. Okay, and that's how the whole over the coalition pair keep the less charge in their formula. Okay, आपका ऊपर में जो n प्लस माइनस है वो आपका मेटल का ही चार्ज दिखाएगा अगर आपका लिगेंड जो कोलिशन पेयर में हो वो कोई एनायन नहीं हो. ठीक है. अगर एनायन हो जाए तो वो थोड़ा बहुत क्या करेगा? चार्ज को न्यूट्रलाइज करेगा. ठीक है, इन कोलिशन पेयर. तो मेटल का जो एक्चुअल जो चार्ज होगा वो ही रहेगा, पर ऊपर का जो कोलिशन पेयर का जो चार्ज है वो रिड्यूस हो जाएगा. वो क्या हो जाएगा? डिक्रीज कर जाएगा. ठीक है. देखो समझ में आया या नहीं आया? Are you understand or not? The metal having the charge, suppose cobalt NH3 whole 3 Cl3. Okay, cobalt actual having the charge +3 because only the +3 oxidation state of cobalt hold 336 ligand. Okay, cobalt 0 never attach with 6 ligand. Cobalt +2 attach with 4 ligand, and only cobalt +3 can accommodate 6 ligand. Okay, by common sense, by bonding concept. Okay. Now in coalition pair this +3 neutralized by 3Cl minus somehow. Okay, that's why the overall charge gets 0. Okay, so this dictation show the coalition pair charge, not the actual metal charge. Okay, clear? आपका जो ऊपर में जो 0 है वो यहाँ पर कोई मेटल का एक्चुअल चार्ज को नहीं रिप्रेजेंट कर रहा है. क्या रिप्रेजेंट कर रहा है? ओवरऑल जो चार्ज है इन कोलिशन पेयर. ओके, सो Here in cobalt, actual cobalt charge is plus 3 because the only cobalt plus 3 holds 6 ligand. Okay. Now this plus 3 somehow neutralized by 3Cl minus in cohesion pair. Cohesion pair means this. Okay. And that's why the overall charge becomes 0. Okay. That means this 0 does not represent here the actual charge of metal. Rather, it represents the overall charge of cohesion pair. Okay, clear that? Okay. Sorry. But if that becomes cobalt, NH3 plus 6, sorry, 3 plus. So here, this 3 plus represent actual cobalt plus the oxidation state. Why? Because there must be no anion is present. No anion is present, so there must be no chance to neutralize the actual charge within a cohesion pair. Okay, so that's why this overall charge show the actual charge of metal. Clear? Okay. Okay. Now ligand any species that may be ion may be molecule ion, like as for example Cl minus, I minus, these are anion or ion, and molecule that may be NH3, H2O, this. Okay, that have at least one lone pair of electrons. At least, that means minimum. Maybe maximum 2, 3, 4 lone pairs may be there, but minimum one lone pair should be there, because this ligand should be donate its lone pair. So there must be one lone pair should be present. Okay, and that can donate its lone pair to the metal cation or atom. Metal cation and atom means cobalt 3 plus may be there. This is cation. And atom, because sometimes nickel CO whole 4. Nickel CO whole 4. Their nickel charge is actually 0. So nickel 0, that means nickel exists as a atom in nickel CO whole 4. Okay, nickel CO whole 4, there must be the actual oxidation state of nickel is 0. So here nickel exists as atom, not cation. Okay. Now M plus or metal. Generally metal should be electron deficient. That means mostly they may be either cation or otherwise they may be atom state. But the atom state is very rare. As for example nickel CO whole 4. So this type of example are very rare. Mostly they are cation. Okay. And that's why they can hold extra electron density from the ligand. Okay. But if this metal gets anyhow electron rich system, so their back donation can be possible. बैक डोनेशन कब होता है? जब इलेक्ट्रॉन डेंसिटी मेटल में बहुत ज़्यादा हो जाता है. दैट शुड बी मे बी ऑक्सीडेशन स्टेट -1, 0, 1 or sometimes +2. On that case, +2. On that case, back donation can be occur. That is M-1, M-1, M0, M+1, M+2. On that case, back donation can be occur. Because electron density that should be increases, so that's why back donation, that means electron density reverse back to the ligand, that should be possible. Okay, आपका जैसे आपको सोचो M नेगेटिव है और C ट्रिपल बॉन्ड O है, तो सी ट्रिपल बॉन्ड वो तो इलेक्ट्रॉन दे रहा है मेटल में, तो मेटल में इलेक्ट्रॉन डेंसिटी और भी बढ़ गया, राइट. When metal having high electron density, so there must be stability also be decrease. Okay, so on that case this electron density also back donated. Okay, this is called as back donation. This is called as back donation. Okay, and back donation only be possible when the oxidation state should be -1 to +2. Okay, on that case back donation can be there. Okay, and also this metal accept the pair of lone pairs, obviously I tell, and that should be behave as Lewis acid. Lewis acid means electron acceptor. Lewis base means electron donor. Okay. Now, when a group of ligands donates its lone pair of electrons, maybe one pair of lone pair, okay, to the metal cation or atom, coordinate bonds are formed. I already tell there must be coordinate bond that should be there. No covalent bond, no ionic bond. Okay, वहाँ पर कोई भी कोवैलेंट बॉन्ड या फिर आयनिक बॉन्ड नहीं होता है, वहाँ पर सिर्फ और सिर्फ कोडेड बॉन्ड होता है. And the product is called as cohesion compound. Okay. Now this cohesion compound can also be called as complex compound. That may be neutral like that way, because the overall charge that should be 0. There are also overall charge that should be 0. Though platinum 2 plus is there, I already tell. Though cobalt 3 plus is there, but the overall charge of cohesion pair, that means this, that should be 0. Okay. There I already tell that is platinum 2 plus is there, cobalt 3 plus is there. See, but the overall charge that should be 0. That means this overall charge means what? This whole over the cohesion pair having the charge 0. Okay. Because this platinum 2 plus neutralized by 2Cl minus. This cobalt 3 plus neutralized by 3Cl minus. So that's why overall charge that become 0. Okay. Ionic, why ionic? Because cobalt NH3 whole 6 3 plus. Though this 3 plus neutralized by 3Cl minus, but we know this is cohesion pair. And these Cl3 are present in ionic pair, that is outside of the cohesion pair. Okay, that's why we called as this is ionic. This is also ionic. Okay, and complex cation anion, because this platinum NH3 whole 4 that should be 2 plus and PtCl4 that should be 2 minus. Okay, this actual charge that is 2 plus, this actual charge is 2 plus. 2 plus or 4 plus? 4 plus. Okay. So this is the combination of cation cohesion pair and anion cohesion pair, and that should be make the complex cation anion cohesion compound. Okay. Now we have to see that should be make it better understand to you, that is what is cohesion pair. This part is cohesion pair. This part is cohesion pair. This part is cohesion pair. Okay. This part is cohesion pair. This third bracket, up to this third bracket is called as cohesion pair. And this part, this outsider of the third bracket is called as ionization pair. Okay. And so when you dissolve this cohesion pair, that should be intact as like it. Okay, जैसे आपका था वैसा ही रहेगा. Okay, the cohesion pair that should be intact. Okay, but this Cl minus which are present in the ionic pair, that is outside of the cohesion pair, that should be dissociate. Okay, and the total of 2 ion, that should be sum up, that is 4 ions. Okay, that should be 4 ions. Clear? Okay. Now remember this 6 means 6 ligand, that means cohesion number. Cn means cohesion number. 6 means what? This 6 means what? This 6 means what? This 6 means 6 NH3 ligand are attached with cobalt in cohesion pair. Okay, that's why this is called cohesion number. Okay, and this is metal obviously, plus 3 oxidation state, and this is ligand, one lone pair. Okay, and this ionization pair determine the oxidation state. Oxidation state of whose? Oxidation state of overall cohesion pair, not the metal. मेटल का जो आपका ऑक्सीडेशन स्टेट होगा वो आपका आयनिक स्पेयर हो या फिर कोहेशन स्पेयर में अगर कोई भी एनायन हो, उसका दोनों का न्यूट्रलाइजेशन करके आप बोल सकते हो कि कैसा कोबाल्ट बोलो, जो भी बोलो, उसका ऑक्सीडेशन स्टेट क्या होगा. ओके, पर आपका आयनिक स्पेयर में जो एनायन होगा वो डिटरमाइन करेगा आपका होलेवर कोहेशन पेयर का क्या चार्ज है. जैसे आपका बोल सकते हैं, जैसे कोबाल्ट, कैसे कहाँ पर, जैसे कोबाल्ट NH3 होल 4 Cl2. कोबाल्ट NH3 होल 3 होल 4 Cl2, बाहर में Cl है. ठीक है, अब देखो ये जो Cl है ये डिटरमाइन करेगा इस होलेवर का क्या चार्ज होगा. इस होलेवर का चार्ज होगा +1. ठीक है, ये होल ओवर कोहेशन पेयर का चार्ज होगा +1. ठीक है, पर आपका ये दोनों जो होता है, ये जो दोनों हैं, ए बी Cl है, ए बी Cl है, ये डिटरमाइन करेगा मेटल का एक्चुअल चार्ज, वो होगा +3. ठीक है, और आपका कोई भी एनायन हो वो आउटसाइड ऑफ द कोहेशन पेयर हो या फिर आपका इनसाइड ऑफ कोहेशन पेयर हो, वो अल्टीमेटली आपका प्राइमरी वैलेंसी शो करेगा. मतलब ये दोनों जो Cl है वो आपका क्या शो करेगा, प्राइमरी वैलेंसी. थोड़ा बहुत प्रॉब्लम हो रहा है ना, रुको मैं फिर से मैं बोल रही हूँ. कोबाल्ट सोचो, NH3 होल 4 Cl2, बाहर में Cl है. ठीक है, फर्स्ट हमको देखना है ऑक्सीडेशन स्टेट, उसके बाद हम जाएंगे प्राइमरी और सेकेंडरी वैलेंसी. ठीक है, फर्स्ट you have to check oxidation state. So there must be oxidation state is basically two types. One is overall cohesion जो स्पेयर है उसका ऑक्सीडेशन स्टेट, और दूसरा मेटल का जो एक्चुअल ऑक्सीडेशन स्टेट है उसका ऑक्सीडेशन स्टेट. ठीक है, आप कोई भी बस में हो, एक होगा आपका बस का डेस्टिनेशन, वो उसका गोल है वो कहाँ तक ऑप्टिमम जाएगा, और दूसरा है आपका डेस्टिनेशन, आप कहाँ पर उतरोगे. राइट, यहाँ पर भी फिर एक ही चीज़ है. एक है होल कोहेशन पेयर का एक चार्ज होगा, वो मेटल का एक्चुअल चार्ज के साथ सेम भी हो सकता है या फिर सेम नहीं भी हो सकता है. ठीक है, और मेटल का क्या होगा, एक मेटल का एक्चुअल चार्ज होगा. ओके, so there must be two type of charges there. One is overall cohesion pair charge, other is metal actual charge. Okay, and this overall cohesion pair charge may or may not be same with actual metal charge. Clear? Okay, Now next one, this Cl is outside of the third bracket, right? This Cl is outside of the third bracket. That means this Cl is from ionic sphere. Okay, that is called ionic sphere. Ionic sphere. Okay, and that determine this overall cohesion sphere charge. That means +1. Okay, and that's why this overall species gets to be neutral. Okay, because Cl minus and this +1 charge, that should be overall make it neutral species. Okay, clear? Up to this clear? I think clear. Okay. Okay, thank you. Now next one. And the previous idea, forget it. Okay. Now these 3 Cl both are anion. Both are anion, not having lone pair but have a negative charge. So these 3 combinedly determine the actual metal charge, that should be +3. Right? Clear? Okay. So the single Cl which is present only in the ionic sphere determine the overall charge of cohesion sphere, and the 3 Cl minus, which there must be one is outside of the cohesion sphere and 2 are inside of the cohesion sphere, determine the actual charge of metal. Okay. And now we have to go primary valency, secondary valency. There must be cohesion NH3 whole 4 Cl2 and there must be Cl. So there must be this 4 and this 2. Inside of the cohesion pair, this number of ligand give the idea of coordination number. Okay, and that is called secondary valency. Secondary valency. Okay, SB means secondary valency. And this Cl minus and this Cl2, that means ultimately 3 Cl minus, give the idea about oxidation state of metal, that is called primary valency. So oxidation state of actual metal, oxidation state of actual metal, not cohesion pair, that is called primary valency, PV. And cohesion number, that is number of ligands attached with the metal, are called as secondary valency. Clear? Okay, next. Now there must be cohesion number. Cohesion number 2. Okay. There must be cohesion number 4. Okay. Cohesion number 6. Okay. Now 1893, Warner, that is famous scientist who produced a theory of cohesion compound, explained the structure and formation of compound. I already say primary valency, that means ionizable, non-directional. Ionizable means only anion play the role, because only anion determine the actual oxidation state of metal. Okay, and this actual oxidation state of metal is called as primary valency. And this primary valency only satisfied by anion. Okay, this anion may be outside of the cohesion pair or inside of the cohesion pair. Okay, and satisfied by negative ions. Clear? Now next valency is secondary valency, that should be directional. Why directional? Because when anions are there, obviously these anions may or may not make a covalent bond with the metal. If anion present outside of the cohesion pair, आपका मैंने क्या बोला, ये जो Cl है ये तो आउटसाइड ऑफ द कोहेशन पेयर है, ये तो कोई कोऑर्डिनेट बॉन्ड नहीं प्रोड्यूस करेगा, पर फिर भी ये प्राइमरी वैलेंसी शो करेगा. राइट? दिस Cl is not present in the cohesion pair, not making coordinate bond with the metal, but still having primary valency. Okay, so that's why in primary valency there must be no uh, mandatory. There must be coded bonds are not mandatory in primary valency. Okay, but in secondary valency we never consider outside of the cohesion pair. We consider inside of the cohesion pair how much ligands are present, how much ligands are attached with the metal. Like this 4 and this 2 are considered. That means inside of the cohesion pair we have to consider how much ligand are present inside of the cohesion pair. Right? That means inside of the cohesion pair all ligands making coded bond. They may be atom, may be molecule, may be anion, may be cation, whichever, but they always make a coded bond with the metal inside of the cohesion pair. That's why they always show coded bond. See that. If there must be cobalt, NaC, whole 4 Cl, and there must be Cl2 and there must be Cl is there. Okay, so we have to consider this 4 and this 2. These are cohesion number. That means secondary valency, right? So that means what? We forget for secondary valency this Cl. For secondary valency we forget this Cl. We only consider this part. This part. That's why we have to consider this Cl2 and NH3 whole 4. Right? So that means this secondary valency only focus on cohesion pair, not focus on ionizing pair. Okay, only focus on third bracket. Okay, so that's why within a third bracket all the molecules, all the atoms, all the anions, all the cations, whichever they attach with the metal by through coordinate bond only. Okay, so that's why primary valency there must be no mandatory issue that there may or may not be coded bond is there, but in secondary valency there always be coded bond is there, because secondary valency only focus on cohesion pair or within third bracket. Okay, and remember that cohesion bond always be directional property. आपका कोडेड बॉन्ड ऑलवेज क्या होता है, डोनर टू एक्सेप्टर जा रहा है, मतलब एक डायरेक्शनल प्रॉपर्टी वहां पर है. ओके, इन कोवेलेंट बॉन्ड देयर मस्ट बी नो डायरेक्शनल प्रॉपर्टी, बिकॉज there must be in covalent bond there are only the mutual electron sharing is there. That means both are responsible. There must be no directional properties there. In ionic bond, there must be highly electrostatic force of interaction is there. So there must be both are responsible, no directional properties there. But in coordinate bond, there must be one donor donates its lone pair or negative charge to the metal. That means one donor is responsible to fully donate to its lone pair to the metal. So there must be a direction of electron from one species to other species that should be done. Okay, so that's why coded bond always be directional in nature. Okay, remember that. Okay, now there must be this cobalt CH. Warner make so many experiment on cobalt Cl3 6NH3. Okay, this all are the old formula. Okay, but here they see one isomer gets yellow color, other compound gets purple in color, other compound gets green in color, other compound gets violet in color, other compounds gets blue green color. So if one formula, one compound is there, so why they show variety of color? So there must be some isomer is there. Okay, so by introducing so many experiments, we get the idea that there must be so many types of compounds are there which show same formula, that is cobalt Cl3 6NH3. Okay, what are those? This First one, cobalt NH3 whole 6 Cl3, where these 3 Cl are present outside of the cohesion pair, outside of the third bracket. Okay, and the oxidation state of metal is plus 3. Oxidation state of cohesion pair, that must be plus 3. Okay, this overall also plus 3, and this cobalt also plus 3. Okay, and cation, one cation is present, and then 3 Cl are present, and total of iron means total of ionizable iron, because कोएशन जो होता है एक थर्ड ब्रैकेट में जो एंटिटी रहता है वो डिसोशिएट नहीं होता है. ठीक है, आप देखो this, the coordination or this third bracket entity never be dissociated. Okay, remember that. So that's why this cohesion compound intact in nature, that is cobalt NH3 whole 6, that should be intact in nature, and the outside 3 Cl minus, so total of 4 ionizable ions are there. Okay, आपका जो cobalt NH3 whole 6 है, ए वाला जो चीज़ है, ये जो थर्ड ब्रैकेट एंटिटी है, ये डिसोशिएट नहीं करेगा. This third bracket entity or this cohesion compound never be dissociated. Okay, this is the phenomena of cohesion compound. This is the difference between cohesion compound and double salt. In double salt, all the ions are dissolved, but in cohesion compound that is not so. This third bracket entity, that means this cohesion compound, this coordination pair never be dissociated. Rather, this ionic pair and cohesion pair should be dissociated. That is, outside of the cohesion pair, so many ions are there, they can be dissociated, and inside of the cohesion pair may or may not have ions, but never be dissociated. Okay. Next, all cobalt NH3 whole 5 Cl, outside 2 Cl2 is present, color purple, oxidation state of metal plus 3, cohesion pair plus 2. Why plus 2? That is, there must be cobalt NH3 whole 5, there must be Cl, बाहर में Cl2 है, तो obviously this Cl2 make a overall cohesion charge, that should be plus 2. Okay, that's why the overall species, that should be becomes neutral, right? Okay, and that's why there must be one cation, anion, the outsider anion are considered 2 anion, and total outsider 2 Cl minus, and inside this whole over the third bracket entity, so that's why total 3 ionizable groups are there, ions are there. Next one, there trans and cis, cobalt NH3 whole 4 Cl2, and बाहर में 1 Cl है. So the trans are green in color and cis are violet in color. Okay, and both case plus 3 oxidation state of metals are there, plus a cobalt 3, and in cohesion pair oxidation state, that should be plus 1. Why? Because cobalt NH3 whole 4 Cl 2 and this Cl, due to this Cl, this overall entity having the plus 1 oxidation state. Okay, and when it dissociated, it produced cobalt NH3 whole 4 Cl2 plus along with Cl minus. So that means 2 ions. So that means 2 ionizable ions are there. Okay, and 1 cation, 1 anion. Clear? Okay, next. Next one, last one, that is cobalt NH3 whole 3 Cl3. So there must be plus 3 oxidation state of metal, cobalt plus 3 obviously, and cohesion pair, that is charge is 0. Why? That is cobalt NH3 whole 3 Cl3. So there must be no dissociation at all, because in ionizing pair no anion is present. Okay, and this Cl3 neutralize this cobalt plus 3, so that's why the overall charge becomes 0. Okay, okay. So this is cohesion pair oxidation state null, cation 1 is present, and anion in our ionizing pair no anion are present, so that should be not there, and total ion are basically not there. Why? Because this molecule in cohesion pair wholly neutral, because this Cl3 neutralize this plus 3 oxidation state, so that's why that is overall charge become 0, so overall that become neutral molecule, behave like neutral molecule, not as ion. Okay, okay. So when you excess Ag plus is given, so there must be AgCl PPT can be formed. So there must be 3 AgCl is there. That means what? There must be the structure is cobalt NH3 whole 6 Cl3. That's why this Cl3 release as a 3 AgCl. Okay, that's why. Next one, cobalt Cl3 5 NH3. There must be 2 AgCl form. Why? Because there must be cobalt NH3 whole 5 Cl2, and from this there must be 2 AgCl can be formed. Okay, there must be 1 AgCl form. Why? Because there must be cobalt NH3 whole 4 Cl2 and Cl is there, so only in ionizing pair 1 Cl is present. Outside of the cohesion pair, that is 1 Cl is present. आपका थर्ड ब्रैकेट एंटिटी के बाहर एक Cl है, that's why this Cl make a 1 AgCl. And this structure is very much simple, cobalt NH3 whole 3 Cl3. That's why the outside here no Cl is present, so that's why no AgCl can be produced. Okay, next. क्लियर? आपका क्या होता है, आपका आयनाइजिंग स्पेयर या फिर आपका थर्ड ब्रैकेट एंटिटी के बाहर जो भी एनायन होगा वो ही पीपीटी होगा. ठीक है, अंदर से कोई बाहर नहीं जाएगा. ठीक है, okay. If the anion is present inside of the third bracket entity, inside of the cohesion pair, this never go outside. This always attached with the metal. But the anion which is present in the outside of the third bracket entity or outside of the cohesion pair, that means the anions which are belong to the ionizing pair, they can be dissociated and they make a PPT. Okay, so simple approach, that is if anion present inside of the third bracket entity, never be dissociated and never make PPT, and if anion are present outside of the third bracket entity, they should make a PPT, they should be dissociated. Simple. Now what I scap. Okay, now double salt. The difference between double salt and cohesion compound. What? That is double salt, like as per example you will well known, that is potash aluminum, that is K2SO4, Al2SO4 whole 3 and 24H2. And next one more salt, that is FeSO4 NH4 whole twice SO4 dot 6H2. You know, many people do the titration on more salt. Okay, you know this color. Okay, so they are basically double salt. Why? Because they should be dissociated in all the individual ions. आपका जो K2SO4 होगा वहाँ पर आप K प्लस को भी पाओगे, SO4 2 माइनस को भी पाओगे, आपका एल्यूमिनियम 3 प्लस को भी पाओगे, या फिर सब पाओगे. ठीक है, सबका इंडिविजुअल कैरेक्टरिस्टिक रहेगा. कोई भी कोहेशन पेयर के जैसा कोई भी ऐसा एंटिटी प्रोड्यूस नहीं होगा. All individual ions should be dissociated. But when you consider when you consider this cohesion compound, there must be one, this third bracket type entity will be there, and one, and the other outsider Cl minus, that should be dissociated, but there still one third bracket entity should be there. There must be no cobalt 3 plus single property you found, no NH3 you found cobalt NH3 whole 6 2 plus. Okay, so that means in double salt, you any type of combination can be there in double salt, but you get each and individual ions characteristics. All the individual ions should be dissociated. But in complex compound or cohesion compound, there must be you get one entity in third bracket. Okay, and this entity never be dissociated. If dissociated, only dissociate the the outside of the ions which are present outside of the entity, outside of the third bracket, they should be dissociated, but the third bracket entity और कोएशन स्पेयर नेवर बी डिसोशिएटेड. आपका जो थर्ड ब्रैकेट एंटिटी होगा या फिर कोएशन स्पेयर होगा वो डिसोशिएट नहीं होने वाला है. ठीक है. So this is the difference between the double salt. Double salt should give the fully dissociation. All the ions should be dissociated and all the ions show their each and individual characteristics. Okay. But when you consider the cohesion compound, there must be the cohesion pair never be dissociated. Okay. Cohesion pair never be dissociated. The third bracket entity never be dissociated. That should be intact in nature. If cobalt NH3 whole 6 3 plus is there, so cobalt 3 plus never be dissociated from NH3 and NH3 never be dissociated from cobalt 3 plus. Okay, this is the fundamental difference between double salt and complex compound. Next one, Warner suggested, that is, these all the phenomena are the present scenario, but there must be brief history is there, because history is very much related to the science. Why? Because all the science, all the mathematics, all the geology, all the physiology having some history background, because there must be so many research, so many exploration, so many discoveries are there, and that should be by years and years renew, more and more research work will be done. Now the modern science will be developed. Okay, so that's why there must be history is very much related to the science. Okay, actually all subjects are related to each other. Okay, so now remember that Warner first discovered that the structure of this is the compound of cobalt NH3 whole 4 Cl2. Okay, this is the cohesion pair, its structure. Okay, इसका आपका ये जो मैंने बोला इसका तो आप कोहेशन पेयर बोल सकते हो. चेक कोहेशन पेयर क्या है. okay. तो पहले इसका जो मैंने स्ट्रक्चर दिया हुआ है जो कोबाल्ट NH3 whole 4 Cl2. Now we can say what is metal, what is ligand, what is cohesion number, what is primary valency, what is secondary valency, what is cohesion pair, what is ionizing pair. You can say, but can you say about structure? So I think if you never know the further things beyond my present lecture, you cannot tell. Okay, but if you read this all of this, so you can tell easily, obviously. So their problem is there. Now there must be structure prediction. Whichever the structure exists, this molecule, okay, this compound. Now Warner suggests there may be the three type of structure may be there. One is hexagonal structure, other is trigonal prism, I think said. Okay, you can correct me, this type of structure, I think trigonal prism, I forget it, so and next one octahedral structure. Okay, so there must be in hexagonal structure we get 3 isomer. In this prismatic structure we get 3 isomer, but in octahedral we get cis and trans isomer. In cis, that means these 2 Cl are cis to each other, and in trans 2 Cl are opposite, that is trans to each other. That means in octahedral only 2 isomer is there. But we always remember, chemistry always focus on एक्सपेरिमेंटल फाइंडिंग्स. आपका जो केमिस्ट्री है, केमिस्ट्री का एक अच्छा खासा फीचर होता है. केमिस्ट्री में आप जितना ही थ्योरी पढ़ लो, वो ज़्यादातर क्या होता है, लैब वर्क या फिर प्रैक्टिकल के ऊपर ज़्यादा फोकस करता है. प्रैक्टिकली क्या हो रहा है, ठीक है. तो प्रैक्टिकली देखा गया कि आपका ये जो कंपाउंड है कोबाल्ट NH3 होल 4 Cl2, ये आपको क्या दे रहा है, 2 आइसोमर दे रहा है. Experimentally, cobalt NH3 whole 4 Cl2 give 2 isomer only. So that means experimentally prove that this compound have the 2 isomer, and these 2 isomer only get from the octahedral structure. Okay, because the prismatic structure as well as hexagonal structure give the 3 isomer, and that is not so. That is not come by experimental finding. Okay, experimental findings suggest that there must be only 2 isomer will be produced. So that means this compound exists in octahedral structure. Okay, and obviously Warner never do the experiment only once, do several times, and all the several times this compound give octahedral structure 2 isomer. Okay. So by this way, by this discovery, there must be further discoveries are there, further exploration are there. Many scientists engage in it. Finally, we get the idea that this type of structure are basically exist as octahedral structure, not hexagonal, not prismatic. Okay. So up to this is the cohesion compound, and obviously if you know the bonding, that is chemical bonding, so you know the cohesion number 6 always suggests the octahedral mostly. Okay, mostly suggest octahedral. If you know the table, that is cohesion number 1, that means cohesion number 2 means linear, cohesion number 3 means diagonal planar, cohesion number 4 means tetrahedral or square planar, cohesion 5 means TBP or square pyramidal. So cohesion 6 mostly give octahedral. So by VBT, by CFT, by bonding, we further can support this, that this compound exists as octahedral. Okay. So up to this, so what I tell about that, brief summary, that is cohesion compound. Cohesion compound is nothing but that is a interaction between metal with the ligand in a coordinate bond. Okay. And here metal is electron deficient, and so that's a metal electron acceptor. And ligand, the electron rich system, it should be donate its lone pair or negative charge, so ligand should be electron donor. And correspondingly, we can say also metal is Lewis acceptor or Lewis acid, and ligand donates its lone pair or negative charge, so that's why ligand are called as Lewis base. Similarly, when a group of ligands are donates this lone pair to the metal, there must be a compound in genite within a third bracket, and they never be dissociated. They become a single entity, that is called as cohesion compound. Okay. Okay. And they may be neutral, they may be cation, they may be anionic. If they are neutral, that means the metal charge neutralizes within a cohesion pair. Okay, in cohesion pair metal charge automatically neutralized. Okay, but if this is cationic, that means the outside of the cohesion pair there may be anions are there. If the cohesion pair is anionic, there should be the outside of the cohesion pair cations are there, because overall the species should be neutral. Okay. And there may be the two type of cationic anionic complexes can also be combined as a complex cation anion. Okay. Okay. Now next one we have to introduce, that is the difference between double salt and complex compound. Double salt always be fully dissociated, and each and every individual cations anions show their respective characteristics and positive test. Okay, but in correlation compound, where the entity is produced, that is the combination of metal and ligand within a third bracket entity, this third bracket entity never be dissociated. Cobalt NH3 whole 6 3 plus never be dissociated. Okay. Next one, with respect to ionizing pair, if 3 Cl minus are present outside of the cohesion pair, that means ionizing pair, 3 AgCl will be PPT will be formed. If 2 Cl minus outside of the cohesion pair, 2 AgCl will be formed. And if 1 Cl minus is present outside of the cohesion pair, 1 AgCl is formed. If no Cl is present outside of the cohesion pair, so no AgCl PPT will be formed. Okay. Next one, cohesion number means what? How many ligands are present around the metal within a third bracket entity, within a cohesion pair. Okay, this is called a cohesion number. Okay. Now there must be again Warner work is there, that is cobalt Cl3 6NH3. This is the old formula, and from there we get so many compound and their color varies. Okay, because their structure varies, so that's why their color varies. And in the chart I give their respective actual charge of the cobalt in all over the cases +3, actual charge of the cobalt +3 in all over the cases, but the due to the Cl are present inside or maybe outside of the sphere, that's why the overall charge of the cohesion sphere that should be varies, that should be changes. Okay, and that's why these Cl minus are present inside or sometimes outside of the cohesion pair. So due to this, the overall ionizable charge that should be varies, that should be changes. And also now we know the primary valency, what is primary valency, what is secondary valency, what is cohesion pair, what is ionizing pair, what is cohesion number, what is metal, what is ligand, what is cohesion compound. But now we have to come on structure of the cohesion compound. So Warner suggests that the cohesion number 6, that means what? This cobalt NH3 whole 4 Cl2, you can sum up 2 Cl and 4 NH3, that means cohesion number 6. So cohesion 6, there must be predicted 3 geometry. One is prismatic structure, other is hexagonal structure, and last one octahedral structure. So Warner see that cobalt NH3 whole 4 Cl2 is taken as an example. So there must be in hexagonal structure 3 isomer will be established. In prismatic structure 3 isomer will be established. In octahedral there only cis trans 2 isomer will be seen. 2 isomer will be seen. So experimentally verified that there must be 2 isomer will be there. So that means this compound exists as octahedral structure. Okay, and this is the beginning of the structure prediction. And there must be so many explorations, so many discoveries, so many scientists are engaged on it. And after that, we get the idea that this cohesion number 6 mostly indicate octahedral structure, and cohesion compound, that means cohesion pair, they are also exist as octahedral structure. And not only that, this cobalt NH3 whole 4 Cl2 also exists as octahedral structure and show cis trans isomerism. Because in octahedral there are only 2 isomer can be there for that compound cis and trans. Cis means 2 Cl will be adjacent to each other, and trans is 2 Cl should be opposite to each other. Okay, so thank you. So after this, and please subscribe.